All right, so today we're going to pull back the curtain on something that powers pretty much every piece of software you touch. It's got a really simple name, the loop. But honestly, without it, your phone, your computer, the entire internet, well, it just wouldn't work the way it does.
So think about this for a second. How do you actually get a machine to do the same exact thing over and over again? I'm not talking a few times. I'm talking millions, maybe even billions of times, without making a single error. That is the core problem that led programmers to one of their most powerful tools ever, the loop.
So, what is this engine of repetition? Well, at its heart, a loop is just a programmer's way of saying, hey, computer, do this, then do it again, and just keep doing it until I tell you to stop. It's really the ultimate tool for automation. Okay, so here's the more official definition. And the most important part is right there at the end, until a specific condition is met. That condition? It's everything. It's the big red stop button that keeps the loop from just running forever and crashing the whole program. You know, we actually see this kind of thing in the real world all the time. Just look at an old school analog clock. The second hand does a full loop, right? And only then does the minute hand tick forward just a tiny bit. That's exactly what programmers call a nested loop. It's a loop running inside of another loop. It's a really cool mechanical version of the same idea. So if you're writing code, how do you decide what kind of loop to use? Well, it usually comes down to two main flavors, the for loop and the while loop. And picking the right one is kind of the first step to writing code that's both smart and efficient. The whole difference really just boils down to one simple question. Do you know exactly how many times you need to do something? If the answer is yes, you're going to reach for a for loop. It's count controlled, which means it's built to run a very specific number of times. But if the answer is no, well, that's when you need a while loop. It's condition controlled, meaning it'll just keep on running as long as a certain statement is true. A for loop is just perfect for those predictable, finite jobs. Let's say you want to print every even number from 10 all the way to 100. You know exactly where to start, you know exactly where to end, and you know how to count up. A for loop is tailor-made for that kind of task. But what about something like, say, checking for new messages in your inbox? You have no idea how long someone's going to be logged in. It could be 5 seconds or 5 hours. This is where a while loop is the perfect tool. The loop just keeps going based on a condition while the user is logged in, and that's totally unpredictable. Now, loops are incredibly powerful, but they're also a classic way to introduce bugs into your code. I mean, if you get just one tiny detail wrong, you can bring an entire application to a screeching halt. So let's talk about a couple of the most common mistakes that even seasoned pros make from time to time. First up, we have the dreaded infinite loop. I mean, this is a nightmare for programmers. It happens when that stop condition we talked about never actually happens. The program just gets stuck, repeating the same lines of code forever and ever, and usually it just freezes the whole thing. And this quote from a Java review course really nails it. If you set up a test condition, you absolutely have to remember to change the thing you're testing inside the loop. If you forget that one little step, well, you're stuck forever. The second big trap is something called an out-of-bounds error. Imagine you've got a list of 4 things. If your loop messes up and tries to grab a 5th thing, the program is just going to crash. Because that 5th thing, it doesn't exist. It's like you're trying to take one more step after you've already reached the bottom of the stairs. And this all comes down to getting your start and end points exactly right. Being off by just one number, programmers have a name for this, they call it an off by one error, is a super common way to cause this problem. It's like trying to read chapter 13 of a book that only has 12 chapters. So, you might be wondering, where did this idea even come from? And what might surprise you is that the concept of a loop is way, way older than the electronic computer. Its roots are actually in mechanics and, believe it or not, even in the textile industry. This timeline is just so cool. I mean, it shows the idea of a loop starts way back in 1804 with the Jacquard loom, a machine that used punch cards in a physical loop to weave these incredibly complex patterns into fabric. Fast forward over a century to the 1950s, and we finally get the for loop syntax that programmers still use today. And then by the 70s, things got even easier with concepts like for each. It's just a great story of an idea getting refined over and over. Okay, now for the really mind-bending part. That simple little for loop or while loop that a programmer types out, that's just the tip of the iceberg. under the hood, your computer is doing an insane amount of work to make that loop run as fast as humanly possible.
The secret sauce here is something called a compiler. You can think of a compiler as an expert translator that takes the code that a human can read and turns it into the raw ones and zeros that a processor actually understands. And these compilers, they are obsessed with optimizing loops, because in most programs, that's where the computer spends most of its time.
And what's really wild is that there's no single correct way to do this. You're looking at how two of the world's most popular compilers, GCC and Clang, handle the exact same loop. They actually rewrite the code in different ways, each one making a calculated bet that its structure is going to be faster and more efficient on the chip. And the tricks these compilers use are just brilliant. Take loop invariant code motion. The compiler is smart enough to find any math inside a loop that never changes, and it just pulls it out. So it only has to do the calculation one time instead of, say, 1,000,000 times. Or loop unrolling, where it literally copies and pastes the code inside the loop to cut down on the overhead. These are just a few of the genius techniques they use to squeeze every last drop of performance out of the hardware. And this brings us right to the absolute cutting edge. That loop unrolling technique we just mentioned, it turns out that figuring out the perfect way to do it is so complex that researchers are now using artificial intelligence to try and solve it. So a concept that started with mechanical looms is now a problem so hard, we need AI to figure it out. So we started with a simple definition and ended up with a problem so challenging that it requires machine learning to solve. It really makes you wonder, if a basic building block like the loop contains this much history and this much hidden engineering genius, what other incredible secrets are hiding in plain sight in the code that runs our entire world?